Today I'm going to talk to you about sublevels and orbitals, and you can find this information in section 5.3 in your textbook. In the last video I talked to you about principal energy levels, and today I'm going to talk about the sublevels that make up those energy levels. So each time we go up and level in energy, so we're higher in energy and a little bit further from the nucleus, we also add an additional type of sublevel. So sublevels are identified by these letters S, P, D, and F. So in the first sublevel, in the first energy level, there's just one sublevel and it's an S sublevel. In the second energy level, you have an S sublevel and you have a P sublevel. And it turns out that there are individual places where the electrons can be within each of those sublevels. So the S sublevel has just one orbital. That's why it's represented here by one yellow box. The P sublevel has 3 orbitals, which are represented by these 3 green boxes in each level. And then the D sublevel has 5 different orbitals, and F has 7. And each one of these orbitals holds 2 individual electrons. So you can see then, since there's one orbital on the first level, that would hold 2. In this second energy level, we have an S and 3 Ps, so we have a total of 8 electrons that could fit in that level, and then so on. So as we get further from the nucleus, we get higher in energy, and we also are able to hold more electrons in each additional energy level. So now I just want to take a moment and show you what these orbitals look like. So the orbital is the region in space where the electron is most likely to be, and that's about a 95% probability that it will be found in that space, because we can't include all 100% because there's always some fractional chance that the electron is all the way out at the edge of the universe. That's just the way quantum mechanics works. But for our purposes, they're going to take on these shapes because we're pretty confident they're going to be found in that general region. So here in this XYZ axis, we have all these little dots. So that's basically the plot of probability where we would find the electron. And so we then take that and create an actual 3-dimensional shape. So this is the probability density for an S orbital. And you can see that the 1s, 2s, and 3s all are spheres, and they get bigger as you go up, because as you go higher in energy, the electron can be further from the nucleus, because the electrons can be attracted to that positive charge in the nucleus. All right, so I do expect you to know the shape of the S orbitals and the P orbitals. And the P orbitals, there are 3 of them, as I showed you on the previous slide, and they all have the same shape, but they go in different directions. So they all have this dumbbell shape that's shown here in green, but one of them would be along the x-axis, one along the y-axis, and one along the z-axis, as shown here. All right, so that wraps up what I want to tell you today about sublevels and orbitals, and we're going to talk a little bit more in class about where you're going to find the electrons in those particular sublevels.